What's up YouTube? DemiHawk89 here with my first solo YouTube tutorial video. Been running recently with Zotis Man and the Pastry. Recently went through a parkour map. Have recently uploaded our first Zelda note block song to be incorporated into our recreation of Zelda's Hyrule. If you're a Zelda fanboy of any age, shape or colour, it'd be well worth checking out when we get it up. It looks to be a hell of a good build. For this video, Redstone seems to confuse a lot of people. It seems to be one of those things you either understand it or you don't. So I'm going to try and demystify a lot of how it all works and what happens. I know there's a lot of wonderful 3D printers, working PCs, and a lot of magical stuff happening with pistons, but most people look at that and go, there's no way in hell I'd have any chance of understanding that. So I'm going to try and break it down a little bit, make it nice and simple. I'm going to deal with two redstone components, very simple ones. We've got the redstone torch, which I'm currently holding, and the redstone dust itself, which basically forms a wire when you place it down on the ground. Torch can go in one of two places, goes on top of the block, or can go on the side of the block. You can't leave a torch hanging in midair, and if you destroy the block that the torch is on, the torch itself will be destroyed. Redstone wire will travel across the top of any block. It can jump down a single level, but it can't jump down any more than that. It will automatically jump across the side of the block. When you do that, you can't actually place onto the side of the block. And I'm destroying my map already. A couple of little exploits that you need to know about that. When you place a redstone torch down on top of a block, if you then feed a current into that block, the torch itself will turn off. This is quite handy for creating most of the basic circuits that you will see. The other exploit you need to know is that if you place a torch on the side of the block and then you run wire across the top and then power it, that will also turn the torch off. So there we go, some basic understanding of how those works. Let's have a quick look at how you can implement it. So I've got two basic circuits to show you, then an advanced circuit, and then two little fun exploits that I use quite frequently. Take it or leave it for what it's worth. If you don't think you want to use everything here, by all means don't have to, but just try to incorporate the most common redstone components that I find. So, you can see the red and blue wall blocks for the redstone circuits. They are my input gates. Basically, the input comes in from that direction. The switches here are just responsible for generating a redstone current. And the green block at the back is where you would have your output. It could be anything that's powered by redstone, from a piston to a door. Anything can go on top of that block and will be powered. So the first one we're looking at is an AND gate. Basically what it means is that you'll only get an output signal, or you'll only power whatever's sitting on top of the green block, if both red and blue are transmitting power. So I'll quickly just demonstrate that. Stick a piston on top of here. As you can see, it's currently compressed. It's not expanded. If I activate the red one, nothing happens. If I activate the blue one, nothing happens. Activate both of them, suddenly the piston pops out. So we'll just take a quick look at how that circuit actually works. You can see I'm using the exploit. When you feed some current into the bottom of a block that has a torch on top, the torch itself will turn off. So both sides, red and blue, will use the same exploit, and these torches are connected by a single piece of redstone wire. What that redstone wire essentially does is use the other exploit, which is the redstone torch on the side of the block, and as you can see, it's currently off because there is a current passing across the top. So in order for this torch to pass some current into this piece of wire and allow the piston to expand, both of these torches must turn off so that this piece of wire no longer causes this torch to be deactivated. So you can see, first torch has gone off, second torch has gone off. You can see the torch is now running, feeding power into the piston, which of course is pushing it up. And that's an interesting little glitch there. Finding bugs everywhere. So how do you implement this into something you're designing? This tends to be more handy for designing puzzle maps. If you require the player to push two buttons, to place two levers down, to be standing on appropriate pressure pads, and they need to do more than one thing at the same time. This is quite handy. As you can see, you can hit the switches as much as you want, but nothing will happen until both of them are on. Quite handy if you've got two players against each other, such as going through a door. And that is what we call the AND gate. Moving along to the next one, we have what's called the XOR gate, or is actually stands for the exclusive OR gate. Don't let all the crazy letters and terminology scare you or sound confusing. Ignore the X for a second. The OR gate, if you think about it like an AND gate, only requires one of these to be active in order for the green block to be receiving power. So let me just stick a piston down on the top of that. So if I hit the red one, you can see it's popped up. If I hit the blue one, you can see it's popped up again. Now that X at the start does stand for exclusive, and what that means is that if both red and blue are on, like you saw on the AND gate, nothing will happen. So red on, it pops up, I switch the blue on as well, and it comes back down. So the exclusive OR basically means that only one of these currents can be feeding in. So we'll just take a quick look at how the components of the circuitry work. You can see I'm using the same exploit again, feeding some current into the block. If I come around to the other side, you can see there are torches on the either side of the block, which have blocks on top of them. What this essentially does is feed current from the torch up to the block above, and you can see that it's pushing a piece of current onto this redstone wire here, which is causing the torch in front of it to be switched off. Further down, you can see there's another exploit that's causing the piston to currently be contracted. If I hit the red switch, you can see power goes in, comes into this block, switches off that one, which switches off the current here, switches off the current here, allows this torch to be active, giving current to the piston. That piston's glitched again. And of course allows the piston to expand. Ignore the contracted one down there. That's a lovely notch glitch. The reason you can't switch both of them on is courtesy of this torch here. As you can see, when I hit the blue one as well, because neither of these torches here are now on, they're not feeding any current into the blocks above them, which means that this piece of redstone no longer has current, which allows this torch to turn back on, and as you can see it feeds current to both sides, which of course causes both of these torches to be switched off and sends no current to the piston. No current, no worky. If I switch one of them off, you can see it pops back up, and of course if I switch both of them off, nothing is going to happen. This is particularly helpful when you only want one input to be able to affect it, not both. Coming across to the last one, and this is a slightly more advanced concept, but as you can see, a significantly more simpler circuit. Don't worry about the fact that it's called an RS NOR latch. That's just some logic terminology. The easiest way to picture this is a memory cell. This is not dissimilar from what goes on inside your PC or Mac or whatever it is you're watching this from. In fact, what it basically does is it stores a single piece of information, similar to the way the binary system works. Binary is how most computers, and in fact most digital operating systems work, and basically has one of two settings, on or off. You can see there are two output panels here, a green one here and a green one here. I'm going to go ahead and plonk some pistons down on top of them. And you can currently see that the one closest is expanded and the one in the background is contracted. So what does this circuit do? Well, you can see we've got two inputs on the front. Let me give the red one a tap. You can see it switches to the back one. Now, what you're probably expecting is if I hit the switch again, they're going to reverse. In fact, it's not going to happen. I could stand here and hit the switch all day. That first piston is not going to pop up back up again. If I go ahead and hit the blue one, suddenly they switch and the back one gets contracted. What this essentially allows you to do is pass in a piece of information to the memory cell and store it for later. When you're building the more advanced circuits, if you've seen the working calculators or computers or 3D printers, they use similar setups to this. They may not use this exact setup, but they use the same kind of principle. The reason it works, you can see both inputs feed into different sides of the circuit. We have this principle again. If you feed a piece of current into the circuit where there's a torch, the torch will be deactivated, as you can see on this side. And because there's no current coming out, obviously this piston is being contracted. On the other side, we can see that because the torch is on, it is being expanded. Now, currently the blue is transmitting power, but because there's nothing to turn off that torch, or at least not until I hit the red block, I can stand here and do this all day, and it won't affect the first piston. So essentially what you create is the ability to store a piece of information. You can send a single pulse, doesn't have to come from a lever, it can come from a button or a pressure plate, and it will send a piece of information down and basically store it. It doesn't have to be a piston, it can be anything you want. I'm just using pistons to demonstrate where the current is going. And regardless of how many times your players or yourself hit the switch or button or pressure plate, it won't be able to change until you hit the second input. So this is particularly helpful if you're trying to build a circuit where you need to remember what the player has entered, or if you're storing basically any form of information. So those are the three basic building blocks: the RS NOR latch or the memory cell, the exclusive OR gate, and the AND gate. Basically they are three primary building blocks for building most of the more complex Redstone circuits. Two other little handy things that I use quite frequently. This is what we call the NOT gate, or an inverter. Fairly simple design, just a single block in the middle, two pieces of redstone wire and a torch. You can see if I plonk a piston down on the green one, it's contracted. If I give the blue switch a flick, it comes back. So switch is on, pistons down, switch is off, pistons up. This is particularly helpful when you don't go into your designs with a lot of forethought and just run redstone everywhere, and then get to the component you actually want to power and realize that you've got the current backwards. When you want current, you've actually got none, and when you don't want it, you've actually got it. So the ability to invert the current in a very, very compact environment. As you can see, there's only 4 blocks that actually make up the entire length of this NOT gate. It's a very simple way to ensure that you have the right form of current reaching your target, be it on or off. So the last quick thing I want to show you is the principle behind the machine gun, if you've seen the machine gun dispenser, and it's what we call a rapid pulsar. So as you can see, 2 blocks side by side, with a gap in the middle. There's 4 redstone torches on either side hanging off the side, and then a whole bunch of redstone wire. And this exploits basically part of the physics of Minecraft to basically overload the circuits, and as you can see, the redstone is flashing quite fast. If I stick a piston down on top of here, you're going to see how it affects it. Of course, if you tie this to a dispenser, it's going to fire out arrows or cake or whatever you like to put into your dispensers at a particularly fast rate. This is a lot faster than any other component you can create using redstone. So this is particularly handy if you want pistons to go up and down fast, dispensers to fire quickly, or if you want to create a door maze where the doors open and close quite quickly. And of course you can use it for anything else that requires a rapid pulse. So I hope you enjoyed that and found it informative. If you would like any more videos, either on Redstone or the other parts of Minecraft, feel free to comment, subscribe, let me know. If you didn't like it, feel free to troll away and dislike. We're all friends here. Otherwise, thanks for watching.